Generation STEM is brought to you thanks to the help from the National Science Foundation and its collaborative association with the Center for Games and Impact, VEME, Eline Media, Haku, and Arizona State University.
In this episode of Generation STEM, a geologist who studies the moon talks about the possibilities of finding water deposits there. Another young geologist simulates the conditions of the inner part of our planet in a laboratory to unveil the messages hidden deep inside our planet. A nursing student knows that very soon she will have the lives of thousands of people in her hands. Students with bad grades get a second chance, and they have the opportunity to study at a STEM school where the last becomes first. Hello, and welcome once again to Generation STEM. I'm Gabriel Salgado. STEM stands for careers in science, technology, engineering, and mathematics, which have become a priority due to growing demand for professionals in these fields and the importance they have for the future of our country. Today we dedicate our first segment to geology, a branch of science that studies our planet, specifically rocks. When she was a little girl, Julie Lee Ann Mitchell read science fiction books during the day and watched the stars at night. This is probably what led her to study aerospace engineering. But she did not stop there. Today she is studying geology to search for water in the moon and other planets. Here she is to tell us about her work.
My name is Julie Lee Ann Mitchell, and I am a graduate student, a PhD candidate here at Arizona State University. And I'm studying geology, so I study water on the moon and water on Mars and try to find where the water is on those planets, and hopefully one day humans can use that as a resource for human missions. When I was growing up, neither of my parents have college degrees, and going to college wasn't really a thing that we thought about. And so they were also I stayed at home a lot. I did a lot of reading on my own. I did a lot of science fiction reading. I read encyclopedias. We actually lived on the bayou in Louisiana, and so I would go out to the bayou and look at plants and animals, and I eventually started picking up rocks, and I found these shiny rocks. At nighttime, I would look at the stars, and so those two things kind of, eventually turn into this looking at rocks that are in space. My oldest sister, she actually ended up going to college, and so she sat down with me and she made me look at websites, and she made me look into different schools and different places I could live, and she made me apply for the FAFSA, which I had never heard of, but that's how I got a lot of the funding to support me to go to college. One day when I was in high school, I showed up and we took this test called the PSAT. And it turns out that test is actually a qualifier for the National Merit Scholarship. And suddenly I got this letter in the mail that said, "Oh, we'll pay for you to go to college." And once I saw that on a piece of paper, that's when I suddenly realized, this is real. I can actually do this. So I actually started out doing aerospace engineering, and I ended up working as an aerospace engineer for about 5 years after I was in college. I didn't want to give up engineering, but I wanted to study rocks, and I love space. And so planetary science, which is what I'm doing now, puts all of those things together. So you have the rocks, you have the engineering, because we have spacecraft that go to other planets and they analyze the surface, and we need to understand how those instruments work to understand the data we get from them. So I'm actually looking for water on other planets. And so on the moon, there is the possibility of large deposits of water ice at the poles. And so that water could be used as a resource for humans. When you look at different materials, like these rocks back here, they have different colors, they have different appearances, and so when we look at those other wavelengths of light that we can't detect with our eyes, but our instruments can, then we can figure out what minerals they are. When we look at a planetary surface, we're looking at a wavelength range where we're actually looking at how the minerals vibrate. And so the minerals actually, they're attached by chemical bonds and they're vibrating at a frequency that we can see from orbit. I have some samples here that are actually different types of rocks that you can find on planetary surfaces. And so the one in the middle, this is actually the most common type of rock that you find in the solar system. This is called basalt. And this is a rock that is produced from volcanic eruptions. And so this is actually a large salt crystal. And so you can see here there's a layer of salt on the surface. And this is actually very, very special because it only forms when you have a standing body of water that's dried out. And so we see this in the desert here in Arizona. We see it in California, all over the western US. We also see this on the surface of Mars. And so what we can say about this is that, okay, when we see these salt minerals, we know there was a standing body of water for a long time. Math is a tool that we use as scientists all the time, and engineers as well. You need to be able to calculate, how much of a rock there is. You need to be able to do calculations to convert the data from Mars to something we can understand here. And so all of that requires math. And then also just getting outside and appreciating the world, I think, is really one of the most important things about being a geologist.
How interesting is Julianne's specialty? As we can see, our infinite curiosity can take us to faraway places. Today we talk about the possibility of living on another planet, but someday that dream may become a reality. Who knows if some of the first settlements of human beings outside Earth will have the name of Julie Leanne Mitchell. Before going to a break, we invite you to visit our website where you will find lots of information about STEM careers. When we return, a young geologist builds a device to detect earthquakes, which results in her switching careers. While some geologists study rocks on the surface of our planet, others research matter deep inside the Earth. This is precisely what Hannah Shamloo does. She is a geologist getting a doctorate in exploration of Earth and space. When she was a child, she dreamed about being an astronaut, but she ended up studying physics. Later on, a teacher encouraged her to get into geology. Let's see her story and the work that takes her on a journey to the core of the Earth.
My name is Hannah Shamloo, and I'm pursuing a PhD right now at the School of Earth and Space Exploration here at ASU. And specifically, I'm a geologist who focuses on processes that happen on our planet, but beneath the surface, so at depth. So our lab here makes magma. So we melt a bunch of material to try to simulate what's happening under our feet. So I've always loved science. Ever since I was probably 5 years old, I've been obsessed with being an astronaut, the stars, planets. But I really got into STEM when I went to college and declared a major in physics. And then I met a professor who did geology, and he asked, hey, do you want to do some research with me if you have some extra time over the summer? I said, of course. And him and I made a seismometer together. A seismometer basically detects earthquakes. And he's the one who actually influenced me to change my major from physics to geology. In this lab, we simulate mantle conditions. So that you know how there's different layers to the Earth? We're focusing on the mantle of our planet. So we melt things in these piston cylinders behind me. We put material in them, we send them to high pressures and temperatures, and we actually melt the material. This is a piston cylinder. This is how we do our experiments in this lab. Basically, this makes magma, and what magma is just melted rock, which is very impressive because if you think about how chocolate melts in your hand, that's just room temperature, right? But when you take things up to much higher temperatures, it takes a lot of energy to melt solid rock. So basically it's a series of metal plates and we stack them just how you see here. We put a tiny bit of starting material in the very center of this vessel right here. So we pump this to bring it to a high pressure, a pressure that would be comparable to something at the depth of our Earth in the mantle. And then We have an electrical current going through this to heat it up really, really hot. So we have a lot of heat, we have a lot of pressure. The combination of those two things melt the material in there. So right now, there's actually an experiment going on right now in this. Right now in the center of this vessel right here, there's a little tiny piece of melted material, which is really cool. So then we shut off the temperature, we shut off the pressure, and all of a sudden that material turns into glass. So this is actually a piece of glass. So these machines do the exact same thing, only this one is manual, so I have to pump it myself. And this one's automatic, so we just press a button and it does all the work for us. And this over here is the pressure controller that actually makes sure that the pressure stays where it's at so we don't have to be here watching the machines throughout the night. My family was very supportive. One of them went to college, one of them did not. But they knew I've always loved science and they knew it'd be a difficult journey, but they were very supportive. So I would tell a young female in maybe high school to study up on your math, take some chemistry, dabble in some physics, and just see which one you like the best. Don't be discouraged. Science is both man and woman world. It doesn't take a nerdy, genius, antisocial type person to be a scientist. It just takes the willingness to work hard and a passion to drive you.
Geology helps us to better understand our world and to find similarities in other planets. Those rocks Hannah melts in her laboratory may provide knowledge about how we can respond to natural disasters made by volcano eruptions or earthquakes. When we return, a young student gets ready to save lives and to help patients in hospital rooms. The teacher of a student that we'll see in our next segment says that in order to work in this profession, it takes more than intelligence. What you need to have is a great heart. Celia Quesada is a young girl who decided to become a registered nurse. She is getting ready at a school that uses state-of-the-art technology where students live real-life situations and solve very challenging problems. Let's allow Celia to tell us about her experience and her dreams.
I am Celia Quesada. I am a nurse and I go to Alamo College. I work as a registered nurse.
I remember when I first started nursing, out of nursing school.
I've already completed a year of nursing before this. I've studied what they call LVN, which stands for Licensed Vocational Nurses. It's a license to work as a nurse, but you need a registered nurse to supervise you. Before applying, there's a list of requirements that are online. They include basic science courses, which are Anatomy 1 and 2, and microbiology, which requires biology as a prerequisite. Since I had a full-time job, I didn't qualify for financial aid, but there is aid out there. There's a lot of help. I just didn't qualify for it. I didn't want to be $45,000 in debt a year. And San Antonio College has the same or higher standards of education that some private schools have. And you get that education at 30% of the price you'd pay for a private school. It's a mini hospital. We have like 12 mannequins or so. One of the mannequins is, it can simulate labor.
Okay, we'll be working with this mannequin today. We are going to deliver her child, okay?
They have computerized rooms that have cameras and speakers, and the mannequin can talk to you. And the teacher can control what happens to the mannequin from an office, and they leave you alone in the room.
Can you give me a cigarette?
George, no, I cannot give you a cigarette.
The mannequins can enter into shock, the mannequin can scream. It gives you the opportunity to work and to put you in these tense situations. And you can even check all of this here. You can check their stomach and everything else, even their vital signs.
They need to be ready. They have the doctor's orders, and we are here observing them. My name is Margarita Garcia, and I work as a professor in the nursing program at San Antonio College. I work with the students that are already nurses and will become registered nurses. In order to be a nurse, I think that more than intelligence, you need to have a big heart. You need to have passion, emotion. You have to want to do this.
I can take this out. When you are a registered nurse, they will show you, you learn more about science. You learn more about pathology. You learn more about how illnesses function and how you can make a correct decision when you're alone with a patient. You can take their blood pressure. You can also check their pulse. This mannequin is also amputated, and so you can practice how to heal a leg amputation. I think it's harder when there isn't a family, when you have a patient that doesn't have a family, when the doctor isn't giving them a lot of hope, when their body is dying, when they're deteriorating and no one is there.
You ready? No, to be clear. Clear?
The nurses that go into the hospitals we go to don't have anyone helping them. They do everything from changing a diaper to checking vitals, reading lab reports, talking to the doctors. There's a high demand for nurses, especially bilingual nurses. Looks like this kid has some blood hidden here. I think he was being mischievous. You need to have a calling for the sciences, and you need to have a passion for helping people.
There is no doubt that vocation and compassion are the key elements in this profession. Like Celia, students in the medical field have to learn not just about science, but the technological advances to save lives and relieve pain. Please do not forget to visit our website for more information on careers, admission to universities, financial aid, and much more. When we return, we'll visit a school which is a paradise of STEM education to encourage those who have fallen behind to get to the finish line. Even though it may seem like a contradiction, this school is dedicated to recruiting high school students with bad grades, but those who still show interest in learning about STEM. We're going to meet Eddie Rodriguez, the principal of a high school in San Antonio, Texas, that specializes in STEM careers. Let's pay attention to what he has to say about this school and the work they do with students who didn't think they had a chance. Many of them are now getting into some of the most prestigious universities in the country.
I am Dr. Eddie Musquiz Rodriguez. I am the principal of the Harlandale STEM Early College High School. It is a school that's focused on STEM, which is science, technology, engineering, and mathematics. In our school, students take simultaneously college classes at Palo Alto College and high school classes. Students can participate in our program when we go and recruit at the middle schools. They must be finishing their 8th grade. We tend to focus on the student from middle school, the incoming 9th grader, who is a B, C, D kind of student, because the student who's normally is already successful will be successful without us and will enter college. So the goal of the early college high school is for students who will enter our school are those that need more opportunities in order for them to enter college and stay in college. So that's the student that we focus on. But we also focus ourselves in the robotics program. We have 5 different robots that the students are working throughout the year. There's a competition for each one. Our students won here in San Antonio at the FRC robotics competition against 600 teams, and therefore they were able to participate in the world and national competition, which will take place in NASA, because they went to participate, and the 2 teams that went, one won first place and the other one won second place. And this is an underwater robot that has to achieve various objectives underwater. So in the science classes, which is the biology, the chemistry, and the physics, the students are focusing on lab activities, the hands-on activities, because that's where we want them to work together to learn those skills that are necessary for the engineering world or in the science world out there. In mathematics, of course, they're solving problems, but they're not just solving problems on paper, but they actually have to come up to the classroom and present their problems and their solutions. And they work problems together in group.
And the labels hanging over the aisle don't make any sense.
The students start taking classes here like a regular student in the high school classes. Then they are transported over to our community college, which is Palo Alto College, and they take college classes. And then they return back and they finish their day off taking high school classes as well. All of the tuition for their college is free. Their books is also free. When they become seniors or in the 12th grade, the student will earn an associate's degree from Palo Alto College, and then about 3 weeks later, they graduate from high school. Here in our school, what we do is we bring in guest speakers to talk to the students about college opportunities and scholarships.
Conrad. Ooh, Conrad.
We also have software and programs that the students can log in. One of them is Career Cruising, where they can input information of their likes and dislikes, and then the program will automatically provide them with any of the colleges and universities that perhaps will best fit the student. Also, we have our counselor here in our school who provides our students with information regarding scholarships and different colleges and universities. So the parents works together with us here at the school, and we're working hard with the student. We will produce a very successful student who is actually going to be leaving our school not only with a high school diploma, but also with a college, an associate's degree from Palo Alto College, and can probably get a job just then if they need to. We're in careers that are actually looking for people to work in those areas.
When we take a look at the prizes these students have won in robotic competitions, we get a clear view of the quality of education they're getting. Something very important to note is that this is a public school and everything is free for the students. This is a great opportunity to learn for those who like STEM. Before saying goodbye, we invite you to visit our website for more information about the careers we have seen today and many more. You can also find valuable information and links to other sites. We've come to the end of our program, and we expect to see you on our next episode. Thank you for joining us. See you soon.